My name's Peter Taylor. I'm a plumbing teacher at Queensland TAFE. I work at the Acacia Ridge campus. The plumbing team at Acacia Ridge have put together some instructional videos on how to service an aerated wastewater treatment system. Aerated wastewater treatment systems are the most common way of achieving secondary and advanced secondary effluent in Australia. The system we're looking at today is an Aqua 2000. The system is capable of treating up to 2,000 litres of domestic wastewater each day, which according to AS 1547 makes it suitable for a dwelling housing up to 10 persons. Aerated wastewater treatment systems should be serviced every 3 months in most cases. Most aerated wastewater treatment systems comprise of a primary chamber, followed by an aeration chamber, then a clarification chamber, and finally a pump-out chamber. Some systems may differ a little from this, but essentially they work in a similar way. The tests and checks we shall be covering include a residual chlorine test, a dissolved oxygen test, a pH test, a clarity test, a check of the chlorine dispenser tube, a high water alarm test, a check of the sediment levels in the chambers, and a check of the pump and irrigation area, and a check of the air blower. Having removed the lids from the system to allow it to ventilate and minimise the risk of inhaling noxious gases from the sewage, we go on to perform the first of the tests, which will be a residual chlorine test. Carefully take a sample of the water from the pump-out well with a dip cup and bring the sample to the surface. There are various methods of testing for residual chlorine, and these test kits are available at any pool supplies, but in this case we're using an ampule. The ampule is placed in the sample and the tip is broken off, allowing some of the sample into the ampule, and the reaction indicates the level of chlorine present in the sample and is expressed in milligrams per litre or parts per million. The acceptable range for chlorine is between 0.5 and 2 milligrams per litre. Less than 0.5 will result in insufficient disinfection, and greater than 2 could be harmful to the environment in the land application area. The used ampule should be disposed of in a sharps container. The second test we're going to perform is a dissolved oxygen test. Using the same sample that we got from the pump-out well, we take a ampule, glass ampule for dissolved oxygen, and break the tip off the ampule, allowing some of the water to come up into the glass ampule and perform the reaction. There are digital meters available to measure dissolved oxygen, but in this case we're using an ampule again. The acceptable range for dissolved oxygen is between 3 and 9 milligrams per litre and is an indication of a healthy environment for aerobic bacteria to multiply. These are the workhorses of the system. Less than 3 milligrams per litre and there will be poor bacterial activity, and over 9 milligrams per litre can result in excessive nutrients such as nitrates and phosphates present in the effluent. It takes about a minute for the reaction to occur, and you can see by the comparator that we are getting an indication of about 4 to 5 parts or milligrams per litre in dissolved oxygen, which is within the acceptable range. The next test we perform is the pH test. The pH is an indication of the acidity or alkalinity of the effluent. It is also done from the same dip cup sample. This test is performed because of the relationship between chlorine and pH levels. The closer the effluent is to neutral, the more efficient chlorine is as a disinfectant. An acceptable range for this is about 5.5 to 8.5 pH, 7 being neutral. We conduct this test by using litmus paper, which is available at any pool supplies, and it has the comparator on the packet, as you can see. The The next test we're going to perform is for clarity. Clarity can be measured in millimetres or nephelometric turbidity units. Measured in millimetres, you simply have a clear tube. The clarity tube is a simple plastic tube with a cross at the bottom and a hole at the bottom of the tube to allow water to be let go so that the level can drop. You fill the tube up with a sample from the pump out well and then let the water out with your finger until you can see the black cross at the bottom of the tube. The amount of water left in the tube is your depth of clarity. Next, we inspect the chlorine dispenser. Carefully remove the dispenser tube. Plastic becomes brittle over time when exposed to chlorine gases. The chlorine tablets should show signs of being dissolved by the effluent passing over them. Replenish the chlorine tablets as required and return the dispenser to its position. Always be very careful when working with chlorine. It's a very poisonous gas. Wear gloves, work in a ventilated area and store in an airtight container. Next, while we're still working in the pump out chamber, we will test the high water alarm float switch. By using the dip cup, we lift the high water alarm float switch into the upright position, thereby triggering the alarm. This alarm can either be a flashing light on the system or it'll be an audible buzzer in the house. Next we go into the clarification chamber. Using the dip cup or something similar, stir up the accumulated sediment at the bottom of the chamber and turn the sludge return valve to the full on position. Allow this to run for 1 to 2 minutes to return this accumulated sludge back to the primary chamber, and then return the sludge return valve to the original position. This should allow between 1 and 2 litres a minute to flow back from the clarification chamber to the primary chamber and should be left in this position. The sludge return operates by Venturi system. The air from the blower is passed down through the smaller of the tubes through the valve. It gets to about 300 ml from the bottom of the bigger tube. It goes back up that tube, causing negative pressure at the bottom. This vacuums the water that's in the chamber up into the pipe and returns it to the primary chamber. Always remember to turn the valve back to its original position, having cleaned the sedimentation chamber out. Next we're going to check the pump in the pump out well and the irrigation area. Using the dip cup, we lift the float switch on the pump to make it operate, and then we go to the irrigation area to check that the sprays, sprinklers are working correctly, that there's no break in the line or leak, and there's no ponding in the irrigation area. We have a look at the height of the sprays. AS 1547 states that the maximum height for a spray should be 0.5 of a metre and the maximum diameter 2 metres. We have a look to check that there is signage in the area to warn the residents that it is recycled water and not suitable for human consumption. The next test we're going to do is for the sediment levels in the chambers. If the sediment levels reach a metre or more, the system must be pumped out. So using a sludge judge, we're going to put the sludge judge out into the chamber to the bottom and then capture a sample of water and pull it to the surface, and that will give us our sediment levels. There are a variety of sediment or sludge judges on the market. They come in all shapes and sizes, and as this video demonstrates, some are more accurate than others. Sediment tests should be conducted at least once a year. They're not necessary at every service. And advise the owner if the sediment levels reach a metre or more. Next we check the air blower. This is normally housed on top of the aeration chamber in its own housing. Carefully remove the lid because nasty little critters are known to live in there, such as spiders and snakes. Take the lid from the air blower cover and switch the air blower off. This will send the alarm or set the alarm off for the air blower by triggering the pressure switch. With the air blower turned off, remove the cover, the lid on it, and take out the filter. Clean the filter. If necessary, replace. Having cleaned the filter, put the cover back on and switch the air blower back on, and it will return the aeration to the aeration chamber and the alarm should cease. That's the end of the tests and checks we're going to perform today. So, lastly, replace the lids and secure them in place. Clean all of your test equipment. Dispose of the gloves into the sharps container. Clean your hands with soap or sanitizer to reduce the risk of ingesting harmful pathogens. Having placed all your equipment back into your vehicle, you must then complete a service report capturing all the results from your tests and checks. A copy of the service report must be forwarded to the local authority, local council within 10 working days of completing the service. Another copy of the service report must be handed to the homeowner. The service report can either be a Form 11 from the QBCC, as stated in the Queensland Plumbing and Drainage Regulations, or an approved form from the local authority. On behalf of the plumbing team at Acacia Ridge, I thank you for watching this video.
Peter Taylor from Outtakes.
Ready?
Yes.
Hi.
Alright.
Okay.
Project your voice to the back.
We start by using a simple plastic tube with a cross at the bottom of it. Clarity can be measured in gloves and something.
Ah!
Oh yeah, I can read my own printing.
Start from the top.